Recording. So, in today's class, what we discuss?
Storage.
Before I move on to the VMware storage, I want to understand how means simple server is there, no? One server is there. HP DL 380 Gen 10. Okay, so it has around six hard disk or eight hard disk in the front. Three, four, five, six, eight hard drives at front loaded. So I want to use these hard drives into my customer environment. Okay, so I never specified this hardware will be installed with Windows or Linux or ESXi. Doesn't matter. Okay, I can install Windows, I can install Linux, I can install ESXi 6.7, whichever. But I want to utilize all these hard drives. So what options we have? If I said I want to install operating system, that operating system and go and sit on these drives only. Is there any other alternate way? Hmm? Hello, speak out quickly.
Hello.
Yeah. Is there any alternate way where you will save your operating system or where you will deploy your operating system in short?
Hard disk.
Yes. Now I want to understand what type of hard disk you have in the market. Hmm? What type of hard disk you have in the market?
SATA, SSD, and USB.
No. SATA, correct. SSD is also correct. Not USB. There is another type of drive called SAS. There are three types of drives in the market. Getting my point? SATA 7200
RPM.
RPM means the motor speed is 7300 200 times per minute. SAS, you have two variants here, 10,000 and 15,000 RPM. Means in short, both are having magnetic disk and motor. In SSD, any idea what is the RPM? Hmm?
No, sir.
Vivek, in your pen drive, is there any motor? Hmm? Use USB drive, pen drive?
Only chip is there.
Yes. Similarly, SSD is only chip. There is no RPM associated with it. There is no motor. There is no magnetic disk. It's just a magnetic, sorry, electronic chip. Okay. So when it comes to fastness, let me see what Google says. What it is saying. Some MongoDB 4K workloads, SATA. SAS and NVMe, PCI NVMe. What is that? Temporary RAM, non-volatile memory express. Okay, so let's skip that for now. Let's understand the performance of these drives at least first. Costing, I need at least a small metrics, man. Giving the metrics, no benchmarks. Let's see. Someone is someone tried something. SSD, HDD, SSD, read, HDD, read, 300 ops, 3000 ops. Okay, SSD write around 2500 compared to the block size. Okay, so HDD write. So 300, 3000, 10 times faster it looks like, right? And also, if you use 256 KB block size, at least, sorry, oh my god, 4 KB blocks, 100 times, and 600 or something, 1000. Okay, 3 times or 4 times faster than your HDD over SSD, right? As per this picture, let's see. Someone says something else. Samsung, read write, read write, read write. Max IOPS, max write, max read, max write. Okay, but I'm not getting what I'm trying to find out. Let's leave it. Don't spend so much of time. Okay, let's say if you are getting this, just an leave an example. I'm not saying exact prices. If it is 1,000 rupees, okay, it might be 1,500. It might be 2,500. Okay, if it is performing at 1x, it might be 1.5x speed, and it might be 3x. If it capacity level 10 TB, let's say it will support huge capacity. Slow, but support huge capacity. SAS 4 TB commonly used public, 1 TB for 250 GB, 1 TB, 2 TB, whatever the drives. Okay, 2 TB or 4 TB depending on the business requirement, but I've seen most of the times 250 GB hard drives and 500 GB hard drives for SSD for what I can say mixed kind of RAID configurations. Mixed kind of RAID configurations in the sense you'll have SSDs and SAS drives in the same what I can say controller. Okay, so in this server, I said 8 hard drives are there. Okay, now I'm planning to install ESXi. ESXi. Okay, so what kind of drives you should insert here? Hmm? Any idea? Hmm? Vivek?
I think, sir, SATA hard drive.
I said SATA is really slow, man. Are you looking for a high performance solution or a cheap solution?
If faster requirement, SSD is requirement.
Okay, mixed kind of requirement, liberal kind of thing. Then
Yes, yes, SAS.
SAS drives. Okay, based on the performance and based on the costing and based on the requirement, you can use any of these three. But globally, only these are the types that are available to store your data. Agree on this point?
Yes, yes.
Okay. So in this server, I can insert. Let me mark green ones as a SSDs and the red ones as a SAS. Okay. I've, I purchased the device like this. Okay. Two SSDs are there and six SAS drives are there. Both SSDs are of 150 GB each. 150 GB each. Okay. And rest of the SAS drives, all the six drives are 1 TB each. Example. Okay, just to understand how it works. Okay. Aim is I don't want to install Windows, I don't want to install Linux, I want to install ESXi. Now, you understand the right concepts? I've told you in the first class. Maybe you guys have seen the videos. First, second, or first or second session. Sunil,
Uh, I'm not seen that video. First one.
RAID 0. What is RAID 0?
80 means two hard disk insert in server.
Okay, RAID 0, striping. RAID 1, mirroring. Okay, means I have a two SSDs. So, can I configure these two drives into one logical drive by using RAID 1? RAID 1 is data mirroring. Means if you create a logical drive using RAID 1, okay, you will get logical drive 0, just an example. Okay, of size, how much size? 150 GB only. Clear?
Yes.
Okay, 150 GB only. Now I have another six drives. I will not touch them. Or what I will do, I will I will create all the six drives in such a way. I will use RAID 5. RAID 5 means parity. N minus 1. 5 minus, sorry, 6 minus 1. 6 minus 1 equal to 5 drives. 5 drives. So you will get 5 TB space. 1 TB is invisible. In this, out of 6, using RAID 5, if you configure RAID 5, you will get another logical drive called 1, logical drive 1 with 5 TB capacity. 1 TB is invisible because that will be used for parity. Okay. Now, logical drive 0, mirroring means if you are saving something on this drive, same thing will be saved on the other drive as well. So that on the front end, you will get only 150 GB visible because you are maintaining two copies of data in two different disks. You getting my point? Okay. Now, on this server, if I power on and install the ESXi, you mount the ESXi, you click next, and when you're trying to install it, it will go and discover hardware. Remember the step? Hmm? Hello.
Hello.
First video, ESXi
Yes,
installation
yes.
and configuration. You have you
Yes,
remember
yes.
the step, or you want me to show you that as well?
No.
Okay. You mounted the ISO and you powered
Yes.
on the host, and it will start mounting your ISO, and it will load the ESXi, and it will discover the drives, and it will show you two drives. Two drives. One is 150 GB, another one is 5 TB. Two drives, two logical drive 0 or logical drive 1. Just for your understanding, I'm explaining. Okay.
Yes, yes.
So you have to select any one to install the operating system. Or if I said operating system, you install the hypervisor. Okay. So which hard drive you will select to install the operating system? Hmm?
Logical zero.
Logical 0. Yes. So you select this and click next, 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 finish, or it will say select the network interface, this and that, everything, and press F11 to install. Agree?
Yes.
Okay. If you press F11 to install, it will copy the ISO file data and it will install it on this logical drive. Means your ESXi is installed on this drive, also on this drive, on the both the drives. Clear?
Yes.
Okay. Once you reboot your disk, you can unmount this ISO file, and you will see ESXi will be booted from this logical drive. Okay. Still, out of this logical drive, only 8 GB or 7 GB space is used, and you will see somewhere around 140 GB free. You getting my point?
Yes.
Okay, we have tested. You can revisit the first video. I created the virtual machine with 15 GB. Okay, and install the ESXi. Once the installation is done, what you can do, if you reboot the ESXi host and try to log in into ESXi host from browser, inside the browser at the storage level, you will see 7.5 GB is free out of 15 GB. 7.5 is used for ESXi installation, and rest of the 7.5 GB is available on the screen. You can watch the first video.
Okay, sir.
Okay, you want me to show that? Okay, so let me go to ES, how to install and configure ESXi. Okay, so machine is created. You can see my screen, right?
Yes, yes.
So once it is loaded, just watch it. Now you see in this screen, in this example, in this example, you will see two lines. One is 150 GB instead of 15 GB. Logical, local, right? Okay, these are the logical drives in real time. Okay, one in this 15 GB, you will see 150 GB, and another one is 5 TB. Two lines will be there.
Yes, yes.
Okay, so you select the 15 GB one, means you selected 150 GB. Okay, at the end, if you log in after the installation, after the installation, if you look at the storage, after you reboot and log in, you look at the storage, you see 7.5 GB is free. Out of 15, 7.5 is gone. Only 7.5 is available for your usage, out of which 1.4 is used by something. Something means this format and overhead, everything is gone, and you see 6 GB is usable, available to your production in this example. So in this example, out of 150, 8 GB is gone, and 4 GB, let's say, overhead for formatting and stuff. You will see 140 GB at this space, free 140 GB. You're getting my point, what I'm trying to explain?
Yes, yes,
Hmm?
yes.
Okay, now I have one more hard drive, one more logical hard drive, which will not show you here. Okay, if I go to storage, if I go to storage, I have some local storage here. Okay, if I go to ESXi host, data stores, only one thing is there, 7.5 GB, 7.75 GB. Okay, so at first stage, the second logical drive is there, no? One, it will not be shown over here. It will not be shown over here. So for that, what you have to do, you have to format the logical drive and use it in VMware understandable format. What is that VMware understandable format? Hmm? Okay, you have a Windows server or a Windows laptop, Windows 10. What is the file system format?
Yep, yes.
NTFS.
Yep, yes.
Okay. Any other file system formats that you are aware of?
In Linux, ext.
Linux ext5, right?
Yes,
In Windows FAT32.
that that it.
Anything else that you are aware?
I think VMware VMDK.
No, 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 that's wrong. Okay, in Windows there is another file system called REFS, Resilient File System, the new one from I guess 2012 or 16 they introduced.
Okay, okay.
Okay, so these are the few file systems we have, and in Linux we have a file system ext5, and in AIX you have a file system called JFS, Journaling File System, JFS, right? Okay. Similarly, VMware has a file system format called, what is the file system format? VMFS. Remember, okay. VMFS is the file system format. Understood? Or any confusion? Just like your Windows, okay. VMware also has a own file system format called VMFS. Okay, let's keep all these things aside. What this file system format will do, or what this file system will do, I have a laptop with laptop with 1 TB HDD. Okay, if I log in into the laptop, I can see 1 TB drive. But I'm saying this is already formatted. What is formatting? What do you mean by formatting?
File system creation.
What it will do? Okay, basically, you said you have three types of disk in the market. Disk is used to save the data. In which format? Zeros and ones, right? So Windows file system has a certain format called NTFS. Okay, whoever has designed this, the logic is it will override those zeros and ones, and it will prepare the platform where Windows can save the data anywhere and Windows can read the data easily. Windows only can understand how to save it, how to read it from that file system. Understood?
Yes.
Okay, fine, keep it. Same hard disk, I'm not using Windows, I'm using Linux operating system. So Linux has something different algorithm called ext5, right? Is the file system format. What it will do using this algorithm or its file system, it will format the drive and it will keep ready for their internal usage, so that in Linux operating system can easily read and write data from hard drive, which Linux can understand easily. Understood?
Yes.
Okay. Now the same hard drive. I have I have hard drive. I have VMware ESXi 6.7 is the system, or you treat this as a OS. Now, what it will do, it will format that 150 GB hard drive is there, no? It will format everything in VMFS format. VMFS means virtual machine file system. Just understand that VMware can understand. Okay, it will format everything in VMware understandable format called VMFS, and it has also some versions: VMFS 5, VMFS 6, VMFS 4 is a file system format. Okay, so in 6.7, what is the VMFS? Okay, VMFS. Several versions of VMFS file system have been released since the introduction of ESXi, VMFS 3, 5, and 6. Okay, so 6 supports. What all the things that 6 supports? They gave you clear cut instructions. What all the things that it can support. Okay, so I'll not go in detail, but understand this is VMware readable or VMware writable format where VMware understand how to keep the data in organized way using VMFS. Clear? So in this example, 0 is already formatted, and out of which 8 GB is already used, and remaining 140 GB is also formatted in VMFS 6 format, and it will be added back to your system when you log in. But this 1 TB is still raw disk, sorry, 5 TB. Logical drive 1 with 5 TB is still raw format, raw disk, raw logical drive. It is not formatted. So how to do the formation? How to format the drive? Let's see. Let's say, for example, I have I have one ESXi which you built. This one. Let me power on. Okay. So ESXi is installed on a physical new drive. Okay, and it is the brand new ESXi which you built last week. Maybe, yeah, last weekend, right? You practiced how to install and configure ESXi. Okay, so the new one which you built, I said I have two logical drives. One is already formatted, another one is there. So not 5 TB, it is just 8 GB in my lab practice. Remember, okay? In real time, you might see the higher numbers, big storage based on the customer requirement, or huge amount of storage based on the customer requirement. But in my lab, it is 8 GB. Okay, so let's see how to add it. So I have a new host called 40.51. So what I will do, I'll keep this aside. I will not touch this. I will create new cluster. Okay, development cluster. It is there now. Now add a host. What is the host name? 192.168.40.51, right? One host
Yes.
discovered. This is the hash key 6.7 ESXi. Finish. So now your host is added. Your host is added here. The new one exit from maintenance mode. Initially it put in a maintenance mode. Now you have host. So I want to find out data stores. No data stores, nothing, zero. But if I check other ESXi host, it is there, no. Okay, but in this host, there is nothing. So what is data store? First of all, before I move on to discussion, what is data store? A data store is a manageable storage entity usually used as a repository for virtual machine files, including logs, scripts, configuration file, disks, and so on and so on. Long description. Okay. So how to explain it in our way? You have a raw disk. Okay. Install a Windows and log in into the server. You will see C drive. Okay. What is this C drive? The disk, right? You call it as drive. Agree or disagree?
Yes, yes.
Local disk, right? Devices and drives, local disk. Similarly, you have a hard drive. You install the ESXi, okay, and log in. You will see that the free space as a separated drive. Okay, the same drive. It doesn't have any name. C, D, E, F, G, H. There is no such names. You can give whatever the name that you want to give. Okay, so data store is a technical word. One, you have another disk, format it and use it. You call it as data store 2. But it is hard to remember, right? How you remember drive 1, drive 2, drive 3? So that is the reason if you log in into my original lab, okay, and go to storage, even it is hard for me to remember. So what I did, SATA non-SSD drive, I named as SATA data store. SSD with 500 GB, I formatted as a SSD. There is another SSD which is 120 GB, formatted as a SSD2, so that I can easily understand. But if you look at the type, I have reformatted this recently by using VMFS 6 because I am using ESXi 6.5. Okay, for each version, the associated VMFS file system version will be there. If you are using 6.0, you will get VMFS 5. If you are using 6.0, you will get VMFS 5. If you are using 6.5 or 6.7, you will get VMFS 6. So these two drives I formatted long back when I'm using this host in version 6.0. So that is the reason why they are still working as VMFS 5 format. This is just a format. It has some limitations and features and additional features along with the version that we can discuss in documentation. Okay, that we can review and discuss in official documentation part. But understand, every disk you can format and use it as a data store. Technical word is data store. Under data store, you will have all your storage. Okay, so this logical drive 1, how many disk in the back end? In this logical drive, how many disk in the back end? Come on guys, fast.
Six.
Okay, so 6 disk, you created one logical drive. If you format and use it in VMware, you will see one data store with 5 TB. But this data store is combination of 6 different hard drives in the backend that you have to remember. Agree? Disagree?
Yes.
Means
Yes. Yes.
inside this data store, if you place any data, it can go and sit anywhere on these 6 drives. You never know. Okay, system is intelligent enough to save the data anywhere. Means you saved 1 GB. Okay, this 1 GB is splitted into 100 MB, 100 MB, 100 MB, 10 100 MB blocks. Example. Okay, Lehman example. So 100 MB can be saved here, another can be here, another can be here, another can be here, and so on like this. All the 6 drives will be saved with 100 MB. Okay, some of the drives will have 200 MB. So when you are accessing this 1 GB data, again all the drives will read the data and hand over to you. This is how it works in the backend. Agree?
Yes.
Okay, now can I create, like for example, I have some empty slots here. Empty slots here. How many empty slots? How many hard drives that internal server can support, or server can support how many maximum number of drives? Up to 16.
16.
Okay, out of 16, 8 is already used, and you got the approval from your business. You purchased another 8 drives, and you created another logical drive with 8 drives. Another logical drive with 8 drives. All are 1 TB. Now, how much space you will get in logical drive 2? This is logical drive 2, right? 0, 1, and 2. This logical drive has 8 disk in the backend. Okay, what is the usable space? I'm using RAID 5.
First one.
I'm using RAID 5. RAID 5 means n minus 1. N minus 1 means 8 minus
Number
1.
of disk. Yes.
8 minus 1 means 7 TB is the logical drive size. Vivek, you're getting what I'm trying to explain here? Hello.
Hello.
Are you are you getting it? What I'm trying to explain?
Mm, Yeah, actually I lost the connection. Then I again joined from phone. So I missed some part, but I'm getting.
Okay, fine. Yeah. Please concentrate and you can watch the video later on. It's not an issue. Okay. Just a more of theory concepts only. I'm not doing any labs.
Yeah.
Okay. So I'm saying
Okay.
your HP server has a 16 slots. Initially you purchased 8. Out of 8, 2 are SSD, 6 are SATA, sorry, SAS, and you already used it. Now you've purchased another 8 drives. All are SAS drives of 1 TB, and you are creating one more logical drive called 2 and using RAID 5. Now how much space you will get? You will get 7 TB logical drive. Okay, if you format this drive using VMFS, again I'm saying VMFS 6, right? You will format the logical drive using VMFS 6, and you can create one more data store, which will be a 7 TB. So like this, you can with this server in this example, if you create the data stores, you will see 3 data stores in the picture. One is 140 GB, another one is 5 TB, not exactly 5 TB, 4.99 TB something. Another is 7 TB, not exactly 7 TB, 6.96 TB or something. Overhead will be gone right after you format, right? Agree or disagree? Okay, Similarly, if you go to my original lab, I have a 3 disk, not the logical drives. It is desktop. It doesn't have any RAID controller. It is standalone drives. Okay, standalone 3 drives, 3 data stores. Okay, same example which I have explained. You will see. You can give any name. Just for my understanding, I gave a name like this. You can give data store 1, data store 2, data store 3. Okay, so data store 1, 150 GB. Data store 2, 5 TB. Data store 3, 7 TB. You will see here in this example I'm trying what I'm explaining. Okay, every data store is formatted with file system called VMFS file system. You agree on this point? Okay. Okay. Now, whenever you format the raw drive, whenever you format the raw drive, you will get a data store into picture. In your lab, if I go back, just to take an example of your new host, doesn't have any data stores. Without data stores, you cannot build the VMs because VMs, what is VM? Again, set of files I explained you in the second class. VMDK, VMSN, VMX, VMX auxiliary, logs, NVRAM, all these files will be there. You will have all these files and you will save it in somewhere. That somewhere is data store. That data store is formatted with VMFS. VMFS will use the logic and it will format the raw disk in the back end. That raw disk is actually holding the data. Clear on this?
Yes.
Hmm? Now, in this picture, you have a host, but it doesn't have any data stores. Let's see if it has any raw devices in the backend or not. Logical drive or a physical drive. Logical drive means using RAID. Physical drive means raw device. It doesn't have any. You doesn't have any RAID controller. Just like my desktop, but you will not use it in your real time. Desktops and other stuff is excluded in real time. So what you will do? You will always see logical drives in your picture. How to check? Go to configure. Okay, storage devices. Okay, you will see some of these devices are showing up. CD-ROM. Okay, leave it. I don't require CD-ROM. And you see there is one 2 GB disk which I cannot use it. There is one 4 GB disk which I can use it. There is another 8 GB disk which I can use it. There are 3 drives, 3 physical drives. Imagine these are physical drives in live example. Okay, but in this picture which I have explained, you should see 140, you should see 5 TB, you should see 7 TB in the picture here. Instead of 8, 7 TB. Instead of 4, 5 TB. Instead of 2 GB, 140 GB. This is what the size is. It should show here in my example I explained. Clear?
Yes.
Okay. So can I use this 8 GB disk, 8 GB raw disk and format it and use it? You can use it, right? Okay. How
Yes.
to use it? Go to host, right click, storage, new data store. Okay, now you have a multiple ways to format. You can create a virtual data store, storage container connected to it. So this is different. NFS volumes, this is again different. I'll explain later. And create a VMFS data store on a LUN or a disk. I have a local disk, so I will use VMFS data store to format. Next, it will show you all the disk. Which one I need to format? I'll say, boss, I will select this 8 GB one. Okay, what is the name I should give? It is easy for me to understand. Local 8 GB disk is the name. Local 8 GB disk is the name I'm giving. Next, you have a two types of file system formats. It will also support the latest one. It will also support the legacy one. Okay, so I will take the new one, VMFS 6. And you'll see it will be formatted, 8 GB will be formatted and the block size is 1 MB. Fine, finish. That's it. It is formatted and the data store is created. Now you click on this host, go to data stores, you will see local 8 GB is formatted with VMFS 6 format, and after you format 7.75 GB is the disk size. Out of 8 GB, overhead is gone and free 6.34, and some rest of the space is in reserve for data store internal purpose. Okay, so if you format the 8 GB, you got 6.3 GB usable space. In real time, if you format 7 TB, you will get somewhere around 6.9 TB, 6.8 TB something. Okay, this you technically call it as a data store. Inside this data store, you will store your virtual machines. Understood? Any confusion? Any questions on
Yes,
this?
sir. No, sir.
Hmm? Okay, now my only question is, this data store is 90% full. This data store is 90% full. This data store is 90% full. Okay, and your manager or your business owner asked you to create a new VMs. If you want to create a new VM, you must have a space. Do you have a space? I said 90%, more than 90% is used, and you don't have any additional space to create a VM. Now what you will do? You go and purchase new hard drive, right?
Yes.
Okay, but the condition is this this physical server will support maximum 16 drives. 16 drives are already inserted. If you purchase additional drives, where you will insert? Hmm?
Uh,
You got
it's
my
not
question now?
possible. Yes, yes.
Then then what you will do? Customer is saying, I need a VM. Please, can you please help me? But these you don't have a space. Even if you purchase the hard drives, you can purchase it at any point of time, but you don't have a space to insert, or you don't have a slots to insert the drives. You are running out of slots. Means your local storage on the system is completely full. Okay, so
Okay.
in short, whatever the discussion we had, we will never use in your real time. Just for your understanding, I have explained you.
Okay.
Okay, means local storage is rarely recommended for usage. You can use it. I'm not saying you cannot use it. You can use it. That is what we are doing since last 10 days. But this we will not use it in real time. Real time you will use network storage. Basically, there are two types of storage: local storage and network storage. So far we discussed local storage. Tomorrow we will discuss network storage. Why we need a network storage? Okay, why can't we use the local storage? That also we'll discuss tomorrow. Understood?
Yes.
Hmm? But the basics must be clear. That is the reason why I explained you the how the local storage works, how you can use it for your day to day and stuff. But in real time, we never use local storage. Please remember.
Okay, sir.
Okay, so I'll stop here. Tomorrow we'll start the discussion on network storage. Okay, if you want to do some R&D, you can search for these things. You can search about these two.
Yes, sir.
Okay, we'll discuss more in detail in tomorrow's or next coming few sessions, at least 5 or 6 sessions. We will discuss these concepts.
Okay, sir.
Okay,
Okay.
yeah. Let me
Okay.
stop here. We'll catch up tomorrow, same time. Thank you.
Thank you, sir.